Okay, hello everybody. This talk is about three resilience patterns out of the box with Twitter's Finagle HTTP clients, which is a mouthful. Well, we will see what it's about. But first, let us tell you something about us. All right. So I'm Effi Bennekers. I'm a developer at ING.
Yeah, I'm Eggie from Buiten. I'm also a developer at ING.
So, well, let me tell you something about me. So I have one big hobby, which is brewing beer. So this is my actual installation in the kitchen. You can still see the arm of my girlfriend at the left side. She is cooking, but I'm cooking something else. And I really love brewing beer. Why is that? Because it's a creative process. So you start with simple ingredients, and you take these ingredients, you mix them together, and in the end you get a result, right? So that's beer. And usually that's really nice. It's actually quite similar to writing software. So you take some simple ingredients and you do your craftsmanship, and in the end it's an application that people hopefully love. So there are quite some similarities in here. So that's something about me.
Yeah. Well, this is about me. One of my hobbies is playing guitar. This is a baby I bought a few months ago, just because there was a big discount in the shop. And apart from the creative part, I also like the learning part. I've been playing for almost 30 years now guitar, and I still have the feeling that I just started. And that keeps me fresh, and there's so much to learn, there's so much to explore, and that's also what I like being a developer. There's always one more thing to learn. And well, if that stops, I'll stop writing software, I think.
Yeah. Okay, well, I hope that never happens.
I just don't think it will.
All right, but what are we going to talk about today? I think we're going to talk about failure. So, failure. What do you think about failure, Eggie?
Yeah, I'm good at failures. I make them every day, but I don't really like it.
Well,
can you help me? You're a smart guy, Effi.
Yeah, sometimes. I really appreciate you being honest about this and liking failure, because we can really use that today, because we're going to talk about it. So, we have a challenge, right? How much uptime does your application have?
Yeah, well, I created this weather API, and I think it's up about 99%, so downtime of 1%.
Okay. And are you satisfied with this?
Well, I used to. I mean, you know how these things go. You make something for your own, and it works, and it's nice, and then you go it out in the open, and then people start using it, and then all of a sudden, I've got users demanding 24/7 a day that my service is up.
24/7?
Yeah, and sometimes they call me in the night, hey, I can't get your weather from your API, what's happening?
Yeah, well, obviously, customers want 24/7. If you ask them, do you want your service to always be up? Yeah, they will say, yes, of course.
Of course.
But, well, let's take a look at this. First, a question to the audience. Please raise your hand if you think that an uptime of 24/7 is possible. I see a few hands. All right. So we're going to talk about whether that's possible, and we'll come back to that later. So most of you think that it is not possible. Well, there are some problems with having an uptime of 24/7, right? Well, your application, Eggie, it has an uptime of 99%.
Yeah.
But just imagine that you have more than one application in a chain of 100 applications, all connecting to each other.
That's a lot.
That's a lot, yeah. It seems like a really big deal. Because if you look at the picture, it's only an uptime, if you have all these in a chain, of 37%. And 37%, well, no single customer will agree with this uptime, right? So that's just during business hours in a shop from 30 years ago, something like that. So we don't want that.
Definitely.
And, well, you might think this is a really funny example or something that is not realistic. But if we look at this, right? So does this look something like you have?
Well, it's maybe not my weather API because it's nice and simple, but I've seen pictures like this with all kind of connections and things that depend on each other and have network connection between them and need each other to fulfill a certain task.
Yeah. Especially with the microservice paradigm, you take your functions and just put them in different components, and still you have to connect these components. But now the networking or the connectivity between these components becomes very important for your program to work. So actually, if you look at some very big enterprise landscapes, often things are really interconnected, and having a chain of 100 applications, it's not that crazy if you think about it, right? This is something that many people also forget about failure. This is actually what your data center looks like. Well, I hope not, but it might. There's a physical component here. See all the wires, see all the hard disks that can break, and maybe somebody will accidentally bump over your server and something will break because of metal tiredness. It's just that physical things tend to break, and they will break. So failure will happen. So even if you think, oh, my service is always up and my software is perfect, it's not only about the software. It's also about this, and this can go wrong. So failure is kind of unavoidable. All right.
So how are we gonna resilience? I see this term. Is that all going to happen to help us with dealing with these failures?
Yes, it's not about preventing failure, really. If you look up Wikipedia, then resilience is something about being able to mitigate the effects of failure. So the impact of your system failing, or one part of your system failing, is lessened as the impact to your service is lessened. So things still fail, but maybe your service doesn't have to suffer that much if you wouldn't have prepared for this. So this resilience is really important. And we're going to talk about resilience. We're going to show you some examples of how you can make your software more resilient. So making them less prone to failure.
Well, can we apply it to my weather API?
Yeah, sounds like a good
Yeah,
idea.
so we have this picture here. The top part is the laptop. Well, you can show it there. It's physical here. We have also the physical and the logical pictures. So there's some monitoring program we wrote, and it's connecting with a client application. So we really do, the client is written in Java, so we really go from one Java program to another just to show you how the technique works. And in the cluster, and it's over there, this nice Pi cluster with 3 Raspberry Pis, version 3, I thought.
Yes.
Version 3. And, well, my weather API is running it. So this is my production system. And sometimes I get called in the night because, well, I have to switch some cables or whatever.
Yeah.
So it would be really helpful if that could be lessened.
Yeah. And these are the physical components, right? So you have your wires, you have your disks here, and there's some network switch. So also switches are sometimes the cause of failure. For example, a firewall that is changed, and then suddenly something doesn't work anymore. So this is really a representation of your physical system. So maybe you can tell us something about what your client looks like.
Yeah, well, this is a piece of code I wrote, and it's using the Apache HTTP client. And so here we create a request, and then we have some Apache HTTP client and execute the test. And well, based on the response we get, if it's in a 200 we say, well, then we have some content we can pass on, and if not, then we are only interested in the status code. It's quite simple. It's just passing through the request we get from the weather API in the box.
All right. Okay, that looks good. Well, let's see it in action, right?
Yeah.
So we have our monitoring website for the weather. Yeah, let's just run a simulation for your weather API. So you have your client.
Yeah, so what you see happening here is we have the weather 1, it's connecting, so my weather 1 is on the weather 1 instance running. Well, we get some temperature, some condition, the wind direction and the wind force, and it's all random data just to show that something is really happening there. We see some statistics at the top. We have a success ratio of 100% now, which is nice. This weather 1 instance itself also has a success ratio of 100%, and it has an average response time from about, well, 70, 80 milliseconds. So, well, this is really nice. What's happening?
Oh, Eggie, what happened here?
Effi, you didn't do it, right?
No, I didn't do it. This just happens, right?
You didn't do it, right? No, I know it. Well, let's put it back. So this I have to do in the middle of the night. I get a phone call, and then it's running again. But still my night sleep got interrupted, and I don't like it, Effi. Can you please help me?
Yes. Yes, there's something to help you. And that is Finagle. So obviously you would have guessed that we're going to use Finagle. You could have guessed by the title of this presentation. What is Finagle? This is the URL to the Finagle site if you're interested. But Finagle has a client and a server part for having high concurrent server-client connections. We're not going to talk about the server part. And it actually can make use of different protocols. So HTTP or any other RPC-like stuff like JMS or database connection, JDBC. This can all be used with Finagle, so that doesn't really matter. So we're going to take a look at some HTTP client resilience patterns using Finagle. Okay, so how does Finagle work? Well, you get a request inside of your Finagle client, and there's something going out. This is being done by filters, and this service calling something else is then combined with filters and your client. So this is actually returning a future. So it is not really a request coming back, it is a future coming back. So this is an example with just one filter. But let's say you have a filter chain, right? You grab your current service and wrap it into another service or filter. And this is in itself a service. And then you take another filter and wrap it around that, and that is another service. So that's kind of like a decorator pattern, right? So this is how you compose your Finagle services.
Can I ask you a question?
Yes.
This rack in and rack out, what are those?
Those are, in this case, maybe JSON messages
So
with
the types.
HTTP.
The types of what's going in?
Yeah, just
it's a
strings in this
type.
case.
So the filter can also change a type
Yes,
of what's
definitely.
going in.
For example, you can get a JSON request in, something simple, and sending a JMS message out. So it can really transform your messages going in and out.
So it's strongly typed.
It is really strongly typed.
I like it.
We will see that in the examples also, that we make a lot use of types there. All right. So, load balancing. That's something that you really use when you want to spread the load, right? When one system is maybe overloaded and you want to have some other system taking some of the brunt so the system doesn't go down. But Finagle has support for that, but there's something else that Finagle does, which is an extra. It detects whether one of the nodes is down. So that's really quite nice. So if you have more than one service and you connect to both of them and one goes down, all the traffic gets rerouted to the other one. So maybe that's something for you, Eggie. Do you have some other service running?
Yes,
maybe?
there's a second service with the same software running on, the same API. Only I try to do it with programmatically, and I got 50% success rate or something, which was still not good enough. And I started thinking about, hey, how I had to detect it, and it was kind of hard. I couldn't do it in one evening ago.
Yeah, now I understand. Well, luckily for you, there's Finagle. We can use that. So this scenario, right? Your
This
connection
is
is
what you
cut.
just did, right?
Yeah, but
Yeah, right.
this is your second service.
Yeah,
We're going
this is
to
my
make
second
use of
server.
this. All right. What does Finagle client look like? All right. First, we start with a simple connection string. So this is connecting to some host called weather1 and weather2, which are the hosts of the services here. And we create a client. We just call new service on it with this connection string and give it a name. In this case, we call it load balancer, but it could have been anything.
Effie,
Yeah.
what are those funny dollar signs in there?
Oh, the host filter dollar
Yeah,
module dollar.
Yeah.
Well, that's something from Scala.
Scala.
So Finagle is written in Scala, and these are some of the things that you get when you use Scala libraries. This should not really be a problem. It's one of the downsides of using Finagle in Java. But if you would have used Scala, for example, this would have looked quite clean. But it still works, and it works perfectly. So if you write some libraries, maybe for conversion, then you wouldn't even notice.
Well, I like to learn, so maybe.
Oh, yes, you will today.
Scala. Yeah.
All right, so sending a request using this load balancing, what does it look like? We just take a request, and we apply a get method on it with some URL. So this is the initial creation of your request. Then we set the host of where the request is coming from. So in this case, my laptop, localhost. Then we apply the request to the client that we created before, and we get a future of a response. And when we just convert it and return it from Spring. Spring will handle these futures for you, and so you don't have to worry about that.
Effie, I'm a bit confused about the future because I see completable future, which I believe is Java completable future, I think.
Yes, exactly.
And this other future, what is in different future? Are we going back to the future?
No, we're not going back to the future. The future that you see here, the future of response, that is a Finagle future, so a Twitter future. And you can write some easy conversion for this to Java completable futures. So that's really easy and quite trivial, actually. We're not going to show you that code.
But that's happening in the toSpring response method.
Yes, exactly.
All right, I'll get it.
So you can convert these futures. All right. Maybe it's a good idea about looking at...
This is it?
This is it? Okay.
All right.
So
Show me.
let's take a look. All right, so let's start a test for this. Here. So now we're running this client. Just a few lines of code. And if we disconnect one of the services, the one that was breaking our system down, now the other one takes over.
We still have an overall success of 100%.
Exactly. So you don't get called at night, right?
No.
Oh, that's
And if you put
that's
it back,
convenient. And when your service is back up again, then this might take a little bit of time. Then your other server will kick in again. So does this help you?
well, this will be awful. This will save me a lot of nightless sleep. But I have this other thing.
Oh no.
Sometimes, and I can mimic it here, my service gives a response not found in let's say 30% of the cases.
It's 30% of the
Yeah,
case.
and I have to press my fresh button in my browser.
Oh no.
I don't like it.
No.
Is there something we can do about that?
Yes, there is something we can do about that. But it's just terrible, right? So you have to retry your web page. So again, a question to the audience with a show of hands. Who has ever gone to a website and pressed the reload button? Yes.
And the rest is lying, I
That's
think.
that's awful, right? So what if your software can do that for you, so you don't have to do it manually? Well, we're going to use a retry mechanism for that. So your weather API, the first one has died already. So you still have one
All right,
one
we
left.
do it on one, then it's easier to demonstrate.
Yeah.
Yeah.
And it has a failure rate of 30%. So how can we mitigate this problem? We're going to retry this. There's a bit of code here. So first we're going to create a retry filter. Remember that you compose your the Finagle services using filters and wrapping them in filters. We're going to create a retry filter with a retry policy. That will be on the next slide. We're just going to give it a timer, in this case a default Twitter timer. You can get some statistics, and we're just passing in a null implementation for that because we're not interested in it right now. And we're going to give it a retry budget.
And this retry budget, it's like a money budget?
It's quite like a money budget. You know, you have a budget, and when it's gone, it's gone. This is built in to prevent your services from retrying forever. So retrying forever sounds bad, and it is, because then your system can crash with memory problems, etc. So we don't want that. So in this case, it will consume some of the budget if there's a lot of retries, and if that's gone, then it will also not retry anymore. Then we create a client. It looks quite similar to what we did before. We just do it a little bit differently because we take the filter and then create the service that we created initially. So here you wrap that service into your filter, which returns the service in itself.
It's like the picture you showed before, right? You have the server here and the filter here, and you just
wrap it around it,
connect
and that composes a new filter. So, about the retry policy. So, this looks a bit daunting. The most important thing about this is that you have to implement something back off at, which will take a retry. It will actually take the number of retries. So if you're at your first retry, it will give you a back off time of 10 milliseconds. This means that it will retry in another 10 milliseconds. If you're at your second retry, because it didn't work either, then you're going to wait for 20 milliseconds, etc., etc. This is something you can implement yourself. You can have something that does it ×2 every time, or whatever suits your case.
It's a bit similar to email servers, right? If an email server can deliver right now, it will try again in a few seconds, and then maybe in a few minutes, and a few hours, a couple of days, until it decides, well, I can deliver it.
It's exactly like
so it's
something
having
like
the chance to get the other party up again.
Yeah. And then you have to define, of course, whether it should retry. So in this case, we're going to look at your response, and we're going to see whether it returned anything and whether it has a status code of 404. So if it did not return anything, we're not going to retry, because then something else is going on, probably, for a use case. If it's anything else than 404, then we're also not going to retry. As you can see, there's some tuple and try. So there's some functional things going on here that you get from Twitter, Twitter Finagle. This is because it's from Scala. So don't worry about it too much. This works. We will prove it.
Yeah.
We will prove it. Yes, exactly. And finally, sending the request. That looks, I said, sending the request. That looks quite the same, right? First you have a request, you apply it to some URL with a get, and set your host, and have a future response from your client applied. Does it look familiar, Eggie?
Well, I think the only difference is the get mapping and the method name, but the code itself looks almost the same as we saw a few slides ago.
It is exactly the same. So in your actual call, sending the request, that code is exactly the same. It's something that you configure in your client that makes a difference here. All right, so I promised you that I would prove this, so let's do that.
Yeah.
All right, so
this is now just calling the weather API.
yes, and this is a perfectly fine service. It works just like it's supposed to.
Yeah, it has the average of 70, 80 milliseconds, like we saw before.
Yeah. Now, there's something here in our console. We can set a failure rate to this. So now we're going to say, okay, 30% of your returned calls are going to be a 404.
You pressed the close, not the update, I think.
I did press the update.
Sorry, I didn't do it.
Did I?
Nothing is... Well, something is... The average is going up a bit.
Hey, did you notice that?
Yeah, it's now 100, 130.
But what do you see on the success rate?
It's still 100. Can you stop this test?
Yes, because
And in
I said I would prove it.
And in the same start my old, because this one.
Exactly. This is what your old service would do.
Yeah.
It is only, well, 70%, around 70% it will succeed. So you saw that in our implementation, there was still a success of 100%. It got some more, it got a little bit of slower. It got some lag because it's trying to, trying again. So 10 milliseconds, maybe 30, maybe 60, maybe 100 milliseconds added. But still,
It still works.
It still works.
Yeah, I still don't have to press my refresh button in my browser.
And you still don't have to get up at night and having people annoyed.
Yeah. I get a lot of sleep in a couple of days.
Can you rerun the previous?
Yes, sure. So this is 100%. The previous one was had an average of about 80 milliseconds, and this has a slightly higher average. So if something like this happens, let's say 50. So now it's failing more, so the average should go up even more. And if I stop this test and go back to our old clients, then it should be around 50% of success. It fluctuates a bit. All right, so with this, you're all good to go, right?
Yeah, this is good. Awesome. But what? I have a question, because we have now 2 instances.
Yes.
We have 2 of those cables we can unplug. What if we unplug both?
Well, then we kind of have a problem, right?
Yeah, I still will be called in the middle of the night.
Yeah. So looking at this cluster, I mean, there must be something else, right? Do we have any other services going on?
Well, there's a very old one at the bottom.
Oh.
It's one of the first attempts, and it's a bit slow, and it doesn't give the winter information, so it's not as cool as the other one.
But you still have it running.
It's still running, yeah.
So how about decommissioning it? No, just kidding. Yeah, okay, well, we can still make use of that, right? So let's take a look at that. So you don't have the wind information in your old weather API, I can see.
Yeah.
And that's the only difference, right?
That's the only difference.
Okay. Well, we can still make use of that, right? Because having a lesson service is still better than having no service at all. Because if you unplug both cables, well, you at least give people the information about the weather except the wind. Because in the middle of the night, people are not going to call you about the wind.
No, they're not interested in the
Only in the
they're-
temperature,
yeah,
right?
yeah.
So, okay. So this is the situation. Both connections are cut. We're going to make use of the old weather API. And as you can see on top, it's about failover, because this is what it's called. If you have a situation from which one service is down, you can fail over to another one, which is for some reason not your primary choice. So this could be because it's slower, because it doesn't have all the functionality, or because it takes a lot of resources, and any kind of reason. But it's a secondary choice, but you can still use it if something else doesn't work anymore. Again, let's take a look at the code. So this is your client setup. In this case, we have two clients, your primary and your secondary. Your primary will go to your good service, and your secondary will go to your old crappy service. We're going to create the primary client with these things, so the new service again, and calling it primary. But there's
Yeah.
something different. Can you spot it?
No fail fast? What does that mean?
No fail fast. Yes. When Twitter Finagle detects a service being down, it will fail fast because it has some kind of circuit breaker mechanism, and this circuit breaker mechanism will kick in after a while when the service is down. We don't want that because we have a way of recovering from it, so we disable it. But by default, it's enabled. Does that make that clear?
Yeah, so it basically means that if all your instances are down, it makes no sense to send in a request, so fail fast.
Exactly.
And throw an
So that's
exception or
usually
whatever.
something that helps you, but in this case, we don't want that.
Yeah.
And we have a secondary client just going to the old weather service. All right, this is the largest slide of the presentation with the most code.
So if we can graph this, then we have graphed the whole concept, the whole presentation.
Well, it's very good if you can grasp it. So first we create a request. We've shortened it here because it's the same as in the other slides. We're going to have our primary client apply this request, and we're going to lift it to a try. This will give us the ability to see whether that call succeeded or not. So that's all it does, and it's a future also of this. So you have a future of a try of response.
Because
And-
a future means, hey, something, you send a request, something to, and you get a response in the future,
Yes,
but you know not sure whether it's failed or not.
exactly. And because we have a try, we've made a try out of this, we can
We
detect
can
whether
reason
it's...
about,
Yes,
all right, makes sense.
all right. So, well, let's take this response, and we can flat map over it, so we can get to the contents, and we can check whether the response is valid or not. So this is something we've implemented to see whether it's valid. And if it's good, then we just return this good service. And if it's not good, then we return the secondary service. Does that sound?
Well, this is
Good.
what you explained about failover. If the primary doesn't work, go to the second to get your result.
Exactly.
Yeah.
So that's what it does. And again, Spring will take this future and convert it nicely for you. Oh, that's a bit fast.
Yeah, we want to show it.
We want to show it, of course. So let's see. We're going to start the tests. Everything should be working, right?
And this is a bit strange. This is the demo effect, I think.
This is the demo effect.
Yeah.
What? Okay.
Oh yeah.
Yeah, let's get rid of this. that explains some of the failures occurring. Thanks for the one who made that excellent observation. All right.
Yeah, it's good now.
Yeah.
So this is basically our load balancing thing, right?
This is our
What
load
do we
balancing thing. Yeah.
And then we plugged some cables.
Well, let's get rid of the first service. So
Yeah.
the second service takes over. And then let's get rid of the second service. And this might take a while, because it's now going to detect a failure. And again, you see the old weather, you see the wind is not coming in, because it is a lessened service. But the service is still up. So
Yeah, we have to. That's a bit technical problem we didn't address, because all our async requests are sent from JavaScript, and we don't. So I hope this is going to work.
and if we plug one of the services back in, it should
Hey.
take over again. Right? So now we have our service back up to the old good level. And of course, if we plug in this one, it will also join again. So this way, even in the case of complete failure of your primary service, you still have a backup. All right, let's stop this. So we've seen some of the resilience patterns that Finagle offers here. Did you like them, Eggie?
Yeah, I really got the message that you have to think about failure, and also at 24 hours is here back here. You asked the audience. I think you should really think about what does it mean for you 24/7. Is it 99%? Is it 99.9%? Is it even higher? And what is your response time? What is your average response time? What is your P99 response time? You have to take those things into account and agree with your customers or your other stakeholders. What is good for us? What is our service 9? Because if you go from, let's say, 95 to 19.6%, maybe you need a complete different data center in a physical other location, and you need to test it, and you need, well, the cost also rises to get really the higher percentage you get, the more it costs. So I think 100% you will never get. You can get close to it, and it's a matter of how much you want to pay to get there. But you really should think about it and design about it and test,
So
like you do with functional things.
yeah. So it's the responsibility of the developer, of the engineer, to have this mindset that they can have these for very low cost, because this is just a few lines of code, and also and get an uptime for almost free. So developing with this mindset really helps your uptime. All right, and we've seen how easy it is to use Finagle for this. 24 hours uptime is not possible. Even Google goes down, but we can get quite far by using this. All right, so that was it. Thank you.